137 meters long, 23 meters wide, 3 full stories stacked like a floating house of 3 floors, and God told Noah exactly how to build it. That is the startling reality at the center of this story, an instruction precise in its proportions, Genesis 6:15, given to a man in a world that had lost its moral compass. Everything that follows, the choice of timber, the way beams were joined, the need for sealing inside and out, the logistics of animal care, flows from that single exacting command. What we will do here is walk through step by step what the ark's construction likely looked and felt like, the site that needed preparing, the forests that supplied the wood, the methods a Bronze Age workforce could plausibly have used to assemble a vessel of that scale, and the theological moments that frame every practical decision. Where the Bible gives specifics, we will mark them. Where reconstruction requires an informed imagination, we will call it plausible, likely, or possible. Not definitive archaeology, but careful, practical reasoning rooted in ancient techniques. Before a single tree was felt, there was ground to consider. The text gives us a hint that moisture was a factor in the world's origins, Genesis 2:6, and the ark, as a giant wooden structure, demanded a firm, level foundation while being assembled. Imagine Noah and his sons looking over a roughly cleared plateau, perhaps a terrace formed by alluvial deposits, and beginning the work of site preparation. For a hull over 137 meters long, a crooked, rocky foundation would spell disaster. Stones would be removed, ruts filled, and low areas drained. They would need to dig shallow drainage channels and possibly pile and compact earth to create a continuous bed for the ark's keel. Compacting could be accomplished by tamping with tampers, by wetting and pressing layers, or by placing woven mats and sand to disperse pressure. These are not modern techniques. They are the kinds of labor-intensive, incremental methods ancient builders used when laying out earthworks and ship berths. Preparing the ground also meant addressing the problem of pre-flood moisture. Genesis hints that the earth released waters, Genesis 7:11-8:2, and older traditions speak of springs and high groundwater. Noah's crew would have to anticipate water seeping up during construction. They might have dug shallow drainage channels and placed layers of gravel and clay to shed seepage away from the building area. Simple, robust drainage strategies that could be executed with stone-tip spades, wooden shovels, and many hours of human muscle. Nothing here requires iron-shod dogs of modernity. What it required was discipline, patience, and an appreciation for how water behaves against earth. With the site level and firm, the next phase focused on timber, both selecting the right trees and getting them to the worksite.
The Genesis instruction does not name a species, but ancient Near Eastern shipwrights favored tight-grained, rot-resistant woods for marine construction. Cypress and cedar are plausible candidates. Both were prized in antiquity for their durability and workability. Cutting and moving trees in a pre-industrial setting looks and smells like what it always has. The axe's bite, the sound of wedges and mallet, the sap scent in the air. Felling might involve careful scoring, cutting a controlled notch, driving wedges to direct the fall, and protecting trunks from splitting with shims. Men would work in teams, one group cutting while another prepared rollers and hauling lines. Transporting massive trunks a mile or more to the building ground is a logistical problem that ancient builders solved repeatedly. Wooden rollers, round logs laid on the ground, combined with ropes and greased paths, make remarkable leverage for moving heavy loads. Oxen or other draft animals might have been employed where available. Where they were not, men could use capstans, lever arms, and systematized manpower. In many reconstructions, teams bound a trunk to multiple rollers and used wooden poles as pry bars to incrementally advance the load. Greasing the rollers with animal fat or resin would reduce friction. In some places, the ground would be too soft. There, temporary trackways of tightly laid branches and turf could spread the load. None of these techniques requires modern machines, just human ingenuity applied to brute force problems over long durations. Once trunks arrived at the yard, shaping began. The ark's dimensions imply long, continuous timbers for the keel and major beams. A single tree rarely yields a 137-meter beam, so builders had to splice shorter lengths into a continuous backbone. The Bible calls for a roof and rooms, but does not describe every structural joint. Reconstructors therefore turn to ancient joinery traditions for plausible methods. One likely approach is a series of scarf joints, tapered overlapping connections that when pegged and reinforced with wooden dowels can form a long, strong beam. Mortise and tenon analogs, where a projecting tenon of one piece fits into a mortise cut into another, secured by wooden pegs, were common in ancient timber construction. Those methods allow long, straight lines without using metal plates. Pegs and stakes, hardwood pegs driven into pre-drilled holes, provide shear resistance, while cross-bracing built into the keel assembly helps resist bending. The keel itself, in our reconstruction, becomes the central spine. Builders would lay the keel segments along the prepared bed, aligning each joint carefully with plumb lines and reference stakes. Plumb lines, simple yet indispensable tools, guaranteed verticality for frames and ribs as the whole rose. Batten boards and chalked lines would transfer the center line along the length, and temporary frames or falsework would trace the future curvature.
The keel had to be massive enough not just to support the hull, but to carry the dynamic forces of waves once afloat. Conceivably, the keel was assembled with internal reinforcing beams running longitudinally, joined by pegged crossbeams at regular intervals. With the backbone in place, attention turned to the ribs, the curved timbers that give a ship its shape. Creating ribs for a hull nearly 137 meters long required a system. Some ribs could have been hewn from single, naturally curved tree sections, where the grain followed the curvature. More often, ribs were built up from laminations, thinner planks bent and fastened to form a curve. In the Bronze Age context, laminating would likely involve steam softening or soaking planks to increase flexibility, then clamping them over molds until they dried into shape. To raise a rib into place would be a mass effect operation, groups of men using levers and triangular lifting frames, employing guide ropes to control motion and plumb lines to ensure alignment. Each rib would be temporarily braced to the keel with wooden wedges and stays until the outer planking tied the structure together. Precision would be gradual. Trial fits, minor reshaping, and repeated checks with a story pole, a lengthwise template representing the planned curvature. As the whole took shape, an immense wooden shell stitched together from many pieces, sealing became vital. Genesis explicitly mentions pitch and covering the ark inside and out with pitch, Genesis 6:14. In ancient practice, this would mean preparing bitumen-like substances and applying them as a waterproofing membrane. Bitumen, a naturally occurring tar-like substance found in the Near East, can be melted and boiled with resins to change its viscosity and adhesive qualities. Archaeological parallels show using heated tar to seal pottery and boats. For the ark, this process would be done carefully and extensively, boiling the raw bitumen in clay or stone kettles over hearths, then ladling or brushing the hot mix onto seams and planks. Workmen would apply multiple coats, building up a continuous layer that penetrated wood fibers and filled gaps. Inside sealing ensured that the living quarters and animal stalls remained dry. Outside sealing defended the hull against the erosive action of water and helped prevent rapid saturation of timbers. Boiling bitumen is a dusty, smoky business. Imagine the smell of resin hanging over the yard, men working in masks made of woven reed or leather, and careful teams testing seams with buckets of water to watch for leaks. The choice to seal both inside and out responds to a basic structural reality. Wood swells and shrinks with moisture. External pitch keeps the wood from absorbing too much water rapidly. An inner coat minimizes dripping and helps the internal environment remain tolerable for animals and humans alike.
None of this guarantees an absolute waterproofness by modern standards, but used skillfully, it produces a usable, weather-resistant hull. This interpretation aligns with the biblical instruction and reflects techniques that ancient shipwrights plausibly knew. Inside the ark, the biblical account specifies rooms or compartments, often translated from a term sounding like kinningen in some traditions, and it gives the three-deck layout, Genesis 6:16. How might that interior have been arranged? Think of the ark not as a single cavernous hold, but as a functioning micro-city with specialized spaces and systems. The lowest deck would likely house heavy animals and stores, situated low to keep the center of gravity down. Middle decks could accommodate mid-sized animals, people, and storage racks for grain and dried food. The upper deck, closer to the main window or opening, would be preferred for birds and lightweight, sensitive items. Stalls and pens would be constructed using removable partitions, pegged into the frames so they could be repaired or reconfigured. Walkways and corridors would allow Noah and his family to move between areas to feed and tend animals. Ramps between levels might be narrow and sturdy, designed more for hauling food sacks and carrying lambs than for comfortable walking. Ventilation poses both a practical and theological challenge. The ark had to keep air moving without letting in rain. Genesis mentions a window or roof opening, Genesis 6:16, and reconstructions treat this as a continuous, long, narrow opening near the top, high enough to admit light and air but designed to be sheltered. Small side vents, shaded by overhangs and coppered or tarred, could provide additional air exchange. Onboard life would require careful management. Animals produce heat and moisture, and their waste must be dealt with. Ancient ships and animal pens used simple drainage channels leading to sumps, and bedding of straw or wood shavings that could be periodically replaced or dried. For a year-long confinement, storage of food becomes a major enterprise. Grain, dried fruits, salted meat, and roots would be stacked in bins and sealed in woven sacks. Storage racks would use the vertical space efficiently. Water supplies might rely partly on stored cisterns and partly on collection systems. The upper deck could be fitted with covered catchments to channel rainwater into sealed jars and barrels, though the biblical flood narrative makes freshwater behavior uncertain. In all these arrangements, cleanliness and order would be both practical and ritual. Orderly pens and careful feeding schedules reduce disease and create a rhythm to the long days aboard. The Ark's door deserves special attention, both for its engineering and for its theological resonance. Genesis is clear. There was an opening in the side, and the Lord later shut him in. Genesis 7:16.
The shape and mechanism of that door are not described in detail, so reconstructions propose a few plausible options. One effective design for a structure of this scale is a vertically sliding door set within a heavy frame, counterweighted to allow manual operation. Alternatively, the door could function on a pivot, a massive plank hung from a vertical axis with a wooden pivot set into heavy sockets. A pivot system would distribute loads into reinforced framing and could be braced with diagonal timber trusses to resist twisting. Whatever the mechanism, the area around the opening would be heavily reinforced with extra framing members, diagonal braces, and pegged joints to transfer loads into the hull structure. If the door did indeed operate on a vertical pivot or sliding track, its seals would be pitch-coated to make the opening as watertight as possible when closed. Yet here, the narrative pivots from engineering to theology. Noah erects the door in the framing, but Genesis insists that when the shelter was complete and the appointed time came, it was God who shut the door. Genesis 7:16. That theological intervention, the Lord's decisive act of closing the threshold, reframes the entire enterprise. Human hands do the work, divine sovereignty determines the timing and seals salvation. The builders could make the best mechanical door possible, but the sacred moment belongs to the divine. When the time for embarkation arrives, the text emphasizes order and divine orchestration. Creation's living creatures appear and enter the ark according to God's command, in pairs or assortments as described in Genesis 7:2-3. This is not simply a matter of rounding up wild beasts, it is a theological event as much as a logistical one. Narratively, we can picture the last hours before the flood as moments thick with tension. Neighbors watching, some mocking, others bewildered, as a procession of animals, domestic and wild, tame and untamed, move toward the ark with an unnatural calm. The Bible records God's initiative in bringing them, Genesis 6:20, Genesis 7:8-9, and so we should treat their arrival as a divinely ordered moment, not as the handiwork of Noah's crew alone. Still, from a practical perspective, the animals had to be settled into compartments thoughtfully. Weight-bearing concerns would require heavier animals be placed low and near the keel, while carnivores might be isolated to limit conflict. Routines would be established for feeding, cleaning, and monitoring the health of the inhabitants. Noah and his family, trained by months or years of preparation, would know how to manage the chaos into an ordered ecosystem. Then the waters came. Genesis describes catastrophic sources, the fountains of the deep and the windows of heaven, Genesis 7:11-12, as contributing to the flood. From a reconstruction standpoint, the result was rapid inundation compounded by extraordinary rainfall.
Imagine the first sheets of rain, turning the yard into a mud plain, the sound of water increasing until it becomes a continuous roar, punctuated by the creak and groan of timber as the ark begins to lift. As the hull becomes buoyant, the builders let go of false work and temporary braces, trusting the joinery and the ceiling. In such moments, the soundscape would be dramatic: thunder and falling rain, the slap of waves against a hull not yet tested, the anxious calls of animals settling into their pens. For 40 days rain falls, and the ark rides the rising seas, Genesis 7:12-17. For 150 days the waters prevail, Genesis 7:24, and life aboard becomes a suspended world of routine, maintenance, and expectation. Life inside the ark during those months would combine monotony with acute moments of fear and awe. Feeding schedules become the heartbeat of existence, morning and evening distributions of fodder, inspection of seals and seams, repairs to tarred patches where wear shows, and the ever-present task of keeping water out. There would be occasions of prayer, moments of staring into the white glare of a watery horizon, and nights when the creak of timber felt like whispering bones. The family's faithfulness to hygiene and order would be as crucial as their faithfulness to prayer. Wooden floors might soak and dry cyclically, bedding would be shifted, rotting fodder burned or sealed. All of these practicalities are plausible responses to the biblical reality of confinement. After months of uncertainty, Genesis narrates God's remembrance of Noah, the sending of a wind, and the gradual recession of waters. Genesis 8:1. The ark comes to rest on the mountains of Ararat. Genesis 8:4. We should not use this moment to claim geological certainties about locations beyond the text, but we can say that the narrative presents a slow unwinding. After the intense duration of flooding comes the slow work of drying and testing the land. Noah sends out a raven and then a dove to sample conditions. The dove returns with an olive leaf, the first sign of life returning to the earth. Genesis 8:11. That small green token is monumental, a sign that soils may again support plants, that roots find oxygen, and that a home might be reclaimed. Finally, when the family leaves the ark, Noah constructs an altar and offers sacrifice, prompting God to establish a covenant with a sign set in the sky, the bow of promise, a rainbow, a visible reminder that the waters will not again sweep away all life. Genesis 9:13-17. Throughout this whole sequence, theological themes pulse beneath the technical steps. Obedience anchors the narrative. Noah receives a command and follows it, not knowing every eventuality, but trusting in the word he received. The ark itself becomes an emblem of human craftsmanship cooperating with divine purpose. The pagan world might have mocked Noah's work, yet that work was faithful effort, skilled labor, and moral resolve.
The Lord's sovereign acts, bringing the animals, closing the door, remembering Noah, frame and transform the technical achievements into instruments of salvation. The ark is neither mere ship nor mere symbol. It is an intersection where faithful obedience and divine mercy meet. It is important to keep one repeated caution in view. When we describe how beams might have been scarfed together, how ribs were raised, how pitch was boiled and applied, or how compartments might have been arranged, we are offering plausible reconstructions. We call these likely methods because they match technologies known in the ancient Near East and because they satisfy the material demands implied by the ark's size and purpose. None of these reconstructions should be read as archaeological proof that a particular technique was used, but rather as an informed, practical mapping of what would plausibly work under the constraints Noah faced. There are particular technical points worth emphasizing because they answer common questions and satisfy the promise suggested by the title, How Noah's Ark Was Really Built, without overstepping into false certainty. First, the method of joining long beams. Ancient timber workers often used overlapping scarf joints secured with wooden pegs. This approach allows a continuous structural member to be assembled from shorter pieces. Second, sealing required both external and internal applications of bitumen and pitch to reduce leakage and to protect the wood. Boiling and combining resin with bitumen would create a more workable compound. Third, the process of lifting large ribs and beams is plausibly explained by levers, A-frames, and coordinated teams using ropes and guidelines. Plumb lines and templates would ensure the whole symmetry. Fourth, ventilation and drainage were not afterthoughts. The textual reference to a window and to rooms suggest planners accounted for air circulation and for organizing animals, which would necessitate simple but effective drainage channels and storage systems. On the question of animals, the biblical text is specific enough to guide our reconstruction. Pairs of animals, and in some cases sevens of the ceremonial or clean varieties, are brought aboard in the numbers God prescribed, Genesis 7:2-3. Whether the animals were all collected by Noah and his crew or led by divine initiative, the text attributes the orderly preservation to God's hand. Therefore, practical arrangements, segregated pens, weight distribution, feeding schedules are plausible necessities, but the movement of the creatures themselves is presented theologically as an act of divine orchestration. The ark, when viewed through both technical and theological lenses, also teaches about priorities in times of crisis. A primary lesson from Noah's work is that faithful labor is not a substitute for divine agency, nor is divine agency an excuse for human passivity.
Noah's skillful execution, choosing and felling timber, perfecting joinery, applying pitch, organizing living spaces, demonstrates human responsibility. God's acts, the animal's arrival, the closing of the door, the recollection that brings the waters down, show divine sovereignty. The two operate together. When Noah finally stepped back onto dry land and offered sacrifice, the story reached a new phase. God set a sign in the sky and made a covenant with creation, a promise that the order of seed time and harvest and human flourishing would continue, Genesis 9:12-17. That covenant is both a theological conclusion and a narrative bookend. The ark ensured preservation. The covenant established a future. The practical efforts of building the ark were not merely for survival, but for participating in the renewal of goodness on earth. To close, imagine once more the yard where it all began, the cleared plateau, the lined-up trees, the smell of fresh-cut wood and hot pitch. Picture Noah and his sons, among whom were Shem, Ham, and Japheth. Picture their wives alongside them, driving pegs, tending fires for boiling bitumen, measuring with cords and plumb bobs, and keeping faith while the townsfolk jeered. Visualize the ark's long, low silhouette emerging from the falsework, the seams blackened with pitch, the window and the side door framed and ready. When the rains began and the ark rose, the work of their hands passed into the hands of providence. That entire sequence, from earthwork to keel, from shaping timber to housing living creatures, from ceiling to survival, is, in the careful reconstruction we have traced, both technically plausible and theologically coherent with the Genesis account. If this level of reconstruction, diagrams of joinery, sectional visuals of compartments, and animation of the hauling methods would help you picture the process, subscribe and check the pinned link for the visual companion to this explanation. The ark, then, stands in the story as proof that obedience looks like steady craftsmanship amid derision, that faith takes a practical shape in daily work, and that divine mercy can utilize human industry to preserve life. We are left with a tension that is also a promise. Human hands build the vessel, but salvation always remains an act of God. The doves return with the olive leaf, the settled ground under the ark, Noah's altar, and God's rainbow covenant close the narrative loop with a note of renewal and assurance, Genesis 8:11, 9:17-17. When we ask how the ark was really built, the answer is not merely a catalog of tools and methods. It is a portrait of disciplined labor shaped by obedience, sustained by hope, and completed by a sovereign act of grace.
If you want a deeper walkthrough of the interior layout, join our follow-up where we diagram plausible stall plans, food storage racks, and ventilation cross-sections. And for a printable timeline and annotated diagrams, check the link in the description.